In this video, I'll be talking about the P-series test. Very easy test. Let's get straight into it. So, P-series test. Okay, if you have a series, an infinite series, where you have the format of some function 1 over n to the power of, let's say, a number p, then you have the proper format to apply the P-series test. Well, you can also do 3 over n of p, of course. Just any constant at the numerator can work. So, how do you use the P-series test? Well, P-series test, super simple. If the exponent p is less than or equal to 1, your series diverges. And if p is greater than 1, your series converges. That is all. That's all P-series test is, and it's one singular condition. But you might be wondering, what about this p is less than or equal to 1 here? Equal to? 1 over n. That means the series 1 over n diverges, stated by the P-series test. Well, that is true, right? The behavior of 1 over n. So let's graph out 1 over n. The behavior of 1 over n does not grow down slow enough in order for your series to converge. It basically doesn't approach 0 quick enough. Now, n squared, 1 over n squared, well, p is greater than 1, right? The exponent on the n value in the denominator is greater than 1. Therefore, this series converges. Let's go ahead and determine if this series diverges or converges. So, what's the p value here? Well, technically, this function, or the series, is equal to 10 over n to the power of 1/2. Well, that means p is equal to 1/2. And remember, P-series test states that if p is less than or equal to 1, the series diverges. Therefore, this series right here diverges. Let's write it with big capital letters to make it dramatic. Let's go ahead and determine if this series diverges or converges. Now, I'm going to put a little bit of more information about the P-series. Maybe I should have put this in the beginning of the video. But P-series is normally what you're not going to get in an exam. You're not going to get something like 1 over 5, n to the power 5. You're going to get something that you have to use limit comparison or comparison test for. And those require you to know what P-series is. So keep in mind, you're likely, unless your professor is like really lenient, you're likely not going to get a problem that's just P-series. You need P-series is like a tool in your tool belt. You need to use all the damn tools to fix something. Well, maybe not all the time, but it's like a tool. It's like only a part of the problem. All right, but it's just an important concept to know. So let's go ahead and look at this. Well, p in this case is equal to 5. Okay. Well, if p is equal to 5, p is greater than 1. Therefore, the series converges. It's pretty easy to understand. And again, I'm going to write in big converges, big red letters to make it more dramatic. Let's go ahead and solve for this. Well, keep in mind, negative numbers still apply to P-series, okay? So p is equal to -3, right? Well, if p is equal to -3 here, right, the exponent is equal to -3, and p is less than or equal to 1, then your series diverges, right? And you can actually check this using divergence test. 10 over n to the power of -3 is just equal to 10 to the power of 10 times n to the power of 3. If you use divergence test here, you're going to get that your limit equals infinity. So divergence test states that this series also diverges as well. So forget, you have a lot of tools in your tool belt. Divergence test is one of them. Hopefully you've learned that before P-series. But really, I hope you understand P-series test by now, because, man, if you don't, shit, I can't help, man. But as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video.